All right, hello again. Now we're doing law of cosines. Law of cosines, if you're given an arbitrary triangle with vertices A, B, and C, with sides A, B, and C, you can find any side or any angle using c squared equals a squared plus b squared minus 2ab cosine of c. All right. The way this works is that if you're solving for c, you need to know the two sides and its included angle, angle C. All right. And as you move around the triangle, b squared would equal a squared plus c squared minus 2ac cosine of b, or a squared would equal b squared plus c squared minus 2bc, the cosine of a. Okay. And you may be thinking that, wow, the beginning of this looks really familiar. And you're right. It is familiar because it's the Pythagorean theorem. All right. When you apply this to a right triangle, give you a real quick, easy one here. So if this is a right angle where these are sides of 3 and 4, and you're looking for your missing side C, C squared would be 3 squared plus 4 squared minus 2 times 3 times 4. Cosine of our right angle would be pi over 2. C squared would equal 9 plus 16 minus 24. Cosine of pi over 2 is 0, right? So c squared equals 25, c equals 5, and that's our regular 3, 4, 5 right triangle given to us. Now, if we're looking for something a little bit more interesting, okay, say that this is, I don't know, 4. We'll make this 12, and we'll make this, I'll just go with the straight up 2 radians. Okay, and we're looking for this missing side x. Okay, yeah, the formula is nice. Yes, the formula is convenient, but what we can do instead is just rely on that relationship of 2 sides and the included angle give us the opposite side. So x squared would equal 4 squared plus 12 squared minus 2 times 4 times 12, the cosine of 2. Now, try not to be a hero. X squared equals, you can type all this right into your calculator. 4 squared plus 12 squared minus 2 times 4. Oops. 4 squared plus 12 squared minus 2 times 4 times 12 cosine of 2. You get 199.9500963, and then take the square root of each side. 14.140 would be our third side. So that's one use of it. The other use of this, besides finding a missing side, is that if you're given a triangle with 3 sides, 9, 12, and we'll make that a 7. All right, if you want to find a missing angle, okay, to find that missing angle, I don't know, let's solve for the smallest angle in the triangle. So we're going to solve for the smallest angle of the triangle. Remember, smallest angle is opposite smallest side. So if 7 is our smallest side, That angle here, we'll call it theta, will be our smallest angle. So if we stick with that concept of two sides included angle equals the opposite side, 7 squared would equal 9 squared plus 12 squared minus 2 times 9 times 12 cosine of theta, okay? Now, one of the things that really worries me, and I've been doing this long enough, is that students tend to forget order of operations, okay? You got to pay attention to that. This 2, 9, and 12 are all being multiplied by cosine theta. So multiplication takes precedence over addition and subtraction. And then, of course, your exponents obviously go first. So 49 is going to equal 225 minus 216 cosine theta. So we'll minus the 25 over. Sorry, minus the 225 over. So if we minus 225 from each side, negative 176 equals negative 216 cosine theta. We'll divide by negative 216. So this gives us 22 over 27. We'll do the inverse cosine. And so we end up with 0.618 equaling theta. So there's the measure of your smallest angle. Now you could go around, solve for another angle, and then use pi to figure out all the angles in that triangle as well. This will become more important when you look at your angle formula, your area formula. Sorry, this will become much more important when you look for your area formula in your triangles in the next video. So, hope everybody's staying healthy and safe. Wash your hands, and thank you for tuning in.